Okay, our next topic on bridge management is DelDOT Bridge Management Program, and Jason Art, the Bridge Management Engineer for DelDOT, will be presenting.
I'm Jason Art, the Bridge Management Engineer for DelDOT. After multiple times of having Dennis ask me if I'll present, I finally said yes. A lot of you might not know, but Dennis actually used to work for DelDOT. And in 2000, he actually hired me out of college. So I always joke with him and say it's the best thing he ever did. At the next break, he can tell you how he really feels. Well, I'm going to talk about our bridge management program in Delaware. Give a little background first, jump into the current state of our inventory, and kind of get into how we manage our bridge assets. Pretty interesting the past day and a half hearing how New Hampshire is. I mean, there's a lot of similarities between Delaware and New Hampshire. One thing, we're both a small state. We have a relatively small bridge inventory. That's not a typo up there. We only have 1,600 bridges. We are centralized, so all of our inspection design and my bridge maintenance engineer, we're all out of our Dover office. Basically, we can be anywhere in the state within an hour and 20 minutes, just like New Hampshire. Also like New Hampshire, DelDOT, they own the majority of the roadways and pretty much own all the bridges. Some other structures we own and manage, overhead sign structures. We actually own 37 dams. They're earthen dams that carry our road, typically smaller dams, but we own them. We're responsible for managing them. High mast lighting structures. We apparently own a parking garage. You ever get the chance to own a parking garage? Run, don't say no. It was a little bit of a political situation how we inherited that. I don't have it up there, but we also have 8 operational movable bridges in the state of Delaware. 1 swing bridge and the rest are bascule bridges. Yeah, I get that. Just as I said, I'm the bridge management engineer, so I oversee the bridge management section. Just a little bit about our core functions. A lot of the functions are no different than the other DOTs here. Obviously inspect the bridges, maintain load ratings, process hauling permits. Big thing is prioritizing bridge needs, maintain the bridge preservation deterioration models. The other thing we do is, we obviously inspect the overhead sign structures, dams. We manage those as well. We also do the cantilever traffic signals. We inspect those for our traffic section because they don't really have inspection personnel, and they're kind of important structures that we've had problems with. So we actually inspect the cantilever traffic signals as well. We do that through a consultant. We don't do that in-house. And the last thing is we respond to high priority reports. That could be anything from a property owner complaint about drainage. It could be a bridge strike. In fact, last week we had 3 bridge strikes. And of course, one was Friday afternoon about 3 o'clock right before Labor Day weekend. So those are always fun. Just a quick view of some of the structures here. You see a cantilevered sign structure upper left-hand corner, high mast light. Got a through girder bridge. It's a fracture critical bridge up in the upper right-hand corner. And then a picture of our dam, one of our dams. It's actually looking at the spillway taken from the dam. Kind of jumping into the current state of our bridge inventory. As I said, we had a little over 1,600 bridges. You can see we have a lot of culverts, and so the 1,600 bridges, that's about half of that are MBI length structures, about half of that are what we call state length bridges. So the majority of our state length bridges are culverts, so that's why that number is so high. See, we have beam bridges. The 22, that little light blue sliver, that's other. We do have 1 cable stay bridge. That's our Indian River Inlet Bridge. It was just completed 3 years ago. Includes our movable bridges, some other complex bridges. I think total we have like 27 fracture critical bridges in the state. So our current condition of our bridge inventory, we have 110 bridge structures that are in poor condition, meaning structurally deficient, that's MBI 4 or less. A little over 300 in fair condition, and the rest are good. Just to kind of summarize, a little less than 7% of our bridge inventory is structure deficient. A little over 25% is fair and poor, or looking at it the other way, a little less than 75% is good. And I'll talk about performance measures a little bit later. So some of the key issues affecting our bridge inventory. So going back to those 110 bridges that are structure deficient, they typically fall into one of these 5 categories here. And it's probably very similar to any other DLT. I mean, you have problems with your RC decks, you have scour, painting, corrosion of your steel bridges, substructure deterioration, which for the most part is typically a result of our joints. We're getting water down to the bearing pedestal because of leaking joints, damaging bearing pedestals, get loss of bearing, stuff like that. I highlighted the first 2 because I'm just going to kind of talk briefly on them because they're kind of specific and kind of interesting. Kind of actually stole this from a previous presentation. So this gives the number of structures for each of those 5 issues. You see I have a little miscellaneous category for 2, but essentially the first 5 make up those 110 structure deficient bridges. This is for the structure deficient bridges, but if you looked at actually our fair bridge distribution, it's kind of similar distribution amongst the types of defects and issues we're having. So the first one here is corrugated metal pipe culvert bridges. We have a pretty big problem with those. And what this chart is showing, if you look at the pie chart on the left, it's a comparison of our C&P bridge inventory compared to the rest of our inventory. And then on the right, it's a comparison of the structure deficient C&P bridges compared to the rest of our bridge inventory. And to kind of summarize here, our C&P culverts make up for less than 15% of our bridge inventory, but they account for over 70% of our structure deficient bridges. So I mean, we have 80 structure deficient C&P bridges. I mean, kind of we have a big issue with C&Ps. And a couple reasons why we have this issue. Starting in the late 70s into the 80s and even into the 90s, we had a lot of old little timber structures on a lot of our back roads. They were deteriorating. We had a real good salesperson come and sell us on steel metal pipe. And so that's what we did, and that's what we ran with back then. We replaced those with steel metal pipe. A lot of these pipes were dropped off the inventory once they were replaced, not really sure why. We kind of realized that back in 2005 and started picking them back up in our inventory. And of course, by this time, where we're finding them, they're in pretty bad shape. On top of that, we every now and then find what we call found bridges, meaning didn't know they were out there. There's no documentation anywhere. The district wasn't really aware of them. We found 24 last year. And you can see a high percentage of them were SD when we found them. Found some more this year. And we actually have what we call a found bridge crusade. And any kind of bridge, really, most of the time they're C&Ps, but sometimes we do find some reinforced concrete pipes, or we found a couple frame culverts. But so that's not helping our situation. And then the last is the expected design life versus average life of our C&P inventory. So if you're looking at this bar chart here, if you kind of focus in on the steel C&P, we're finding that in Delaware, at least, we get maybe 30, 32 years out of our C&P pipe culvert. The average age of our C&P pipe culvert is 35. So obviously, you know, we're in deep here. We are finally past the bubble a little bit, the peak of the graph, but we're expecting the next 10 years that probably each year for the next 10 years, we're probably going to have another 12 to 15 C&P bridges become deficient each year. So I mean, we need a way to address that. They're small structures, but unfortunately, I mean, if they get kicked to bridge design, they have to go through the full bridge design process. It's a lot of resources for such a small structure, and we're talking a lot of, 15 bridges per year that come SD. It's a lot of bridges for us to work on. I think, unfortunately, some of our fair bridges have been taking a little bit of a backseat, and I'll kind of discuss that in a little while. Jump into our reinforced concrete deck issues. Probably preaching to the choir here, but least for by Delaware standards, the past 4 or 5 years, we've had some really harsh winters. And someone mentioned earlier that, point out a good point that in the Northeast, once it kind of gets cold here, it typically stays cold. Whereas in Delaware, we can go a week or two where it's really cold and we get a break. So we have a lot of different freeze-thaw cycles. And then with the snowplow damage and de-icing agents, the past 3 or 4 years, once winter ends, a lot of our bridge decks, there's just potholes and spalls everywhere, a lot of deterioration. Trying to keep up with that and keep that patch, it's been a huge effort. Some other things that we noticed: inspection limitations. When I first started here in 2000, I actually started out doing bridge inspection. The traffic is nothing like it was today. It's just amazing. You can't necessarily get to all the areas you need to inspect unless you close lanes down to do a deck sounding. You don't really know what the deck is on the travel lanes. You can sound the shoulder and you can do a little bit along the joint, along the shoulder, but you really can't get into the lanes. Whereas when I first started, you could get a good break in traffic, kind of run out there, do some random sampling or random sounding. You can't even really do that nowadays. Our traffic section for our interstate bridges, and they're kind of starting to extend that to some of our expressways now. They require nighttime lane closures, so it makes it harder to inspect that bridge and really do a thorough job of looking at that bridge and identifying deterioration. And then sound. What I might hear as a D-Lam, someone else might not hear, or vice versa. So I guess what I'm trying to get at is there's some inspection limitations that I think over the years have kind of been affecting the rating of our decks, and maybe we actually have some worse decks than we're really seeing out there. And I'll kind of discuss that a little bit more later. Interstate deck bubble. We only have maybe, I'm not sure of the exact mileage, it might be 40 miles of interstate, It's a relatively small amount. Quite a few bridges, pretty much all those bridges when they were built with asphalt overlay. That lasted not too long, and starting in the early 70s, 80s, and 90s, they replaced that with concrete overlay. Well, those concrete overlays are coming due. And this is the interstate we're talking about. So we know that over the next 10 years, we're going to have a problem on our hand with decks, and we're already starting to see it. We're already having a lot of issues with our decks on the interstate. And then just past project decisions, whether it be material selection, it's not selecting the proper material for the right type of application, or decisions were made last minute during a project, and either the proper thickness of the structural overlay was not put back on, so now we have a deck that might be 7 inches thick where it should be 8. So that deck's going to flex a lot more. We've had a few of these, and they've had 3 punch-throughs in the past 2-3 years. So trying to address that, it's been tricky. So how does DelDOT manage how do we manage our bridge assets? In Delaware, we use what is called deficiency formula. And it basically starts out with the bridge inspection. So our bridge inspectors go out, they inspect the bridge, they break the bridge down into elements. We've been doing element level inspections since 1997, I believe. So we've been doing them for a while. Have used PONUS since 1996, 1997. So they inspect each element of the bridge. Of course, you assign different quantities to each condition state for that element. And just kind of gives, this is actually for this bridge here, you see in the picture. It's a 9 or 10 span bridge, carries 4 lanes of traffic. The data is not real important here, but you get a sense of the number of elements we have for that bridge, and then there's different condition states and different quantities in those condition states. So within PONUS, and I guess eventually AASHTO BRM, we have preservation and deterioration models that we had created, and we have done that for each element. Along with that, we have work actions associated, different possible work actions associated with each condition state for each element. So once the inspections are done and we go through this process, run the database, it goes to a bridge, looks at the elements for each element, for each condition state. It runs the preservation deterioration models, determines the lowest long-term cost, like basically it determines its recommended work action based on the longest term cost, and does that for each condition state for each element for each bridge. And then kind of going from there, it calculates that total for all the elements for each bridge, and if we get at least $1,500 in recommended work actions from that process, it spits it out to what we call as our deficiency list. That threshold, we're actually looking to up it. It was, I think, about 10 years ago when that was set, and the idea was 1 day's worth of work for a 3-man crew. So that deficiency list then goes to and actually has what we call the deficiency formula applied to it. So for each bridge on that deficiency list, the deficiency formula is calculated. The deficiency formula is essentially it's a set of factors that have different weights, and depending on certain factors for each bridge, it gets different weights for each of those factors, and you get assigned deficiency points. So for each bridge, you'll get a deficiency point, and the list will be ranked by deficiency points. So the higher number of bridges, the higher number of deficiency points, the higher up that bridge will be on the prioritization list to be worked on. The deficiency formula factors, it's kind of broken down into 2 general groups, conditional factors and then functional importance. I don't know if you guys can see this, but this just kind of lists the different factors. So I'll just list them real quick. Health index, benefit to cost ratio, whether or not the bridge is structure deficient, whether or not the bridge is scour critical, load capacity, functional class of the roadway, detour length, whether or not the bridge is historical or whether or not it's fracture critical, and then the truck ADT, or truck percentage, I should say. And then the percentages of the most points you can get for that category. And this just kind of spits out what the list looks. So when the deficiency list is run, it basically dumps it out into a spreadsheet, and that way we can modify it and add comments as needed. And so what we do is, by February 1st, usually we have our database, our bridge database finalized for the MBI submission. And then over the course of February, March, we go ahead and run the program and get the deficiency list, and then we do some spot checking of it, do some reviews, and then start inputting comments in there, whether or not a lot of the bridges might already be in the system and project may be initiated. So we'll go ahead and note that. And then we'll usually meet mid-April. We'll meet with our bridge design section, and we actually just sit down, we go through the deficiency list. We start with the first bridge and just work our way down. If the bridge is already in the system, meaning a bridge, it's already got a project initiated, we'll just do an update. Is it still on schedule for whatever time we said? Yes, no, what are the reasons? Is there some hold up, whether it be utilities, right away, whatnot? And if we come to a bridge that is new on the list, we actually bring it up right then and there. We'll bring up pictures and discuss why it is, why it's on the list, what type of work it needs, and basically we'll kind of identify the mechanism for addressing the work needs, whether it needs to be a bridge design project, whether it's something our in-house maintenance crews can do, or whether or not it's going to be some of the different projects that bridge management will actually put out, like a paint project or structure maintenance contract, and I'll get into some of that a little bit. But we do that for the whole. We usually try to go far enough down the list to where we have enough work for the next couple years. Usually that's down to like maybe 200 on the list. So addressing bridge needs. We have really 3 main categories. And in-house maintenance, and I'm going to be honest with you, our in-house maintenance is nothing like what I hear from some of these other states. We do very limited bridge maintenance work, mainly just because we have a small amount of resources and they wear multiple hats. They could possibly be mowing grass, setting up MOT somewhere. They also do bridge work. They could be working on a sign structure, guardrail. We don't have dedicated bridge crews. The one thing they do good though, or at least our 2 districts, our 2 southern districts, is they're good at replacing CMP culverts, which has really helped us. Probably on average, they're able to replace 12 CMP bridges that are structure deficient. So that's really helped in trying to keep up with those and addressing those. They do get into some minor concrete repairs and a little bit of minor scour repairs and erosion. We're actually looking to, with one of our districts, kind of resurrect their bridge crew that they used to have and try to get them doing some more maintenance stuff. We'll see how that goes. And then we have a second one there, structured maintenance contracts. I really probably should have labeled that bridge maintenance contracts. So what bridge management does is we actually have a structured maintenance contract. It's an open-end structured maintenance contract for each of our 4 districts. It's for 3 years, and there's a set type of work, preventive maintenance agreement that we had worked out with the feds of work that they can do on these preventive maintenance agreements. Those are some of the major ones, but there's other stuff as well. Then we also have our paint program, which I forgot to put in here, but we try to do a yearly paint project that we put out and try to get 3 or 4, maybe 5 bridges painted. On top of that, we used to have years ago a pile jacketing program. It kind of went away. We're actually looking to resurrect that because we definitely have quite a bit of steel monotube piles and tidal water that have some significant corrosion issues. We feel that doesn't necessarily need to be replaced. We can address it by just pile jacketing and preserve it. So we're looking to resurrect that a little bit. And another thing we're looking to do is actually improve our preventive maintenance, what we do in-house, and try to do with some additional stuff. Or some of the preventive maintenance we do, we don't do it routinely enough or consistently. So trying to improve upon that. We're actually looking to put out a deck sealing contract. Hopefully by this time next year that'll be in place. So I mean, we definitely see that there's some improvements we need to make on the preventative maintenance side to preserve our bridges. So hopefully another couple years, some of those things will be in place. One other mechanism, and I didn't even think about it until here in New Jersey speak, but our 8 movable bridges, we've been trying to get an open-ended maintenance contract to do routine maintenance on our movable bridges. We spoke to a couple different companies. We're just really, right now, we're looking at the budget and trying to see if we can get funding. But basically, that contractor would be responsible for the routine maintenance and respond to any bridge malfunctions for those 3 years, and be a great burden lifted off our 2 districts that have bridges, movable bridges. Right now, we do very limited routine or preventive maintenance on our movable bridges, and it shows. We've had probably 3 or 4 malfunctions, probably 5 or 6 malfunctions over the course of the summer, and it's always on a weekend. That's when the boaters are going through, and a couple of them are in very high touristy areas. A couple of them are not the only way in, but the main way into resort towns, and you get it backed up on Saturday, and the traffic's backed up for miles, and it's just a complete nightmare. So hopefully by doing the routine preventive maintenance on these bridges, having a dedicated open-end contractor out there that takes full responsibility of that, we're hoping that can really help with those issues. Hopefully, we're probably looking at a 2-year time frame to kind of get that in place. Then last is bridge design. Bridge design, they'll do major rehab type work and then obviously bridge replacements as well. One thing I thought was pretty interesting, I hear when I was talking to a lot of people, it sounds like there's a big disconnect between the bridge maintenance and the bridge design people. I'd hear comments like, it's whatever our designers decide to do. It's kind of interesting, and I guess we're fortunate that we're centrally located. We're in Dover, which is the center of the state. Our bridge design section, they're right next to us, and we have quarterly meetings where we meet with them and we discuss new SD bridges we're finding during inspections, or new bridge issues we're seeing, updates on projects, and we really work together as a team. And there's a lot of back and forth, and there's a lot we do on our side that we see on the bridge maintenance side that we try to work with bridge design to improve. And an example that I forget if it came out from this morning's activity, but designing new bridges so you can easily jack them if you have to in the future to replace bearings or do maintenance. We constantly go to bridges and either the diaphragm's just not sufficient to jack from, or the substructure unit itself, there's just no room. And trying to just make some simple modifications in new bridge designs to allow for that, to make it easier on us to be able to go in there and work. And they have started incorporating that to a lot of their new designs. So items like that, and really good team effort trying to tackle our bridges and manage our bridges. So performance measures. I mean, to have an effective bridge asset management program, you need a way to measure how you're doing, how effective is the program. In Delaware, it's pretty simple. We do anything less than 5% structurally deficient, that's our goal. And then, depending which way you want to look at it, less than 25% of the bridge inventory in fair or SD, or greater than 75% good. Those are our goals, those are our measures. So as I mentioned earlier, when I was talking about the condition state of our bridge inventory, we're not meeting those performance standards. So we're not exceeding it by much, but definitely, we have to do something better than what we're doing. So how can we improve the bridge program? Over the past year and a half, probably even 2 years, I've noticed that we're not really getting to our bridges that are in fair condition. We're not really getting to those soon enough. Part of that is just because we're so inundated with the structure deficient C&P bridges and trying to get those replaced, and sometimes closing roads or posting roads. It's been hard to get to them, but we need a better way to address our fair condition, because we want to prevent the bridges from getting from fair to structure deficient condition. So some different things we're doing. We're actually in the process of making modifications to our deficiency formula. We'll incorporate that next year. And basically, we're assigning points. We realize that our fracture critical bridge, they can get, if we have a fracture critical bridge, it can get 10 points, 10 deficiency points. And what we're finding is that we've had a couple fracture critical bridges that were worked on 3 years ago. They're in pretty decent shape right now, but they're still kind of high on the deficiency list. And the reason is because we have such a high number of points given to that bridge just because it's fracture critical. So what we did is, well, what if we only did 5 points? And we took that additional 5 points and gave it to bridges that are in fair condition. And actually what we ended up doing, we did a little sensitivity study with the data. When you have 1,600 bridges, you can do that pretty easily. And what we did is, we don't have a structurally deficient category now. It's not one of our factors. It's what it is. We have 20 points. So if you have an SD bridge, you can get 20 points. Or if you have a fair bridge, you can get 10 points. And what we did a whole bunch of, like I say, a sensitivity study compared to from what we did early in the year with our deficiency list to this new method. A lot of the fair bridges, they now come higher on the list. And because in the past, what we were finding is a lot of our SD bridges, they would get to the top of the list. The problem wasn't the SD bridges, but you would see a lot of sixes, MBI sixes, up high on the list. And a lot of the fives, I mean, there were some fives, but not a lot of the fives. A lot of the fives were kind of lower. So by doing that, we're able to bring the fives up. And so what that allows, when we meet yearly and go through our deficiency list, those MBI 5 bridges will be up higher. We can get them programmed earlier before that way they don't get the SD condition. As I was talking about earlier, we need more emphasis on preventative maintenance. We're going to try to do some things there. Addressing our CMPs quicker. We're actually looking to do a similar project to what Pennsylvania did. Their design build P3 project, a little bit smaller scale. But what we're doing is we're putting a huge project out to address, I think it's 40 bridges or so, that CMP bridges that are currently MBI 5. And it'll be a design build team. They do all the work. They get all the permits, do all the plans, right away, utilities, all that. And then what that allows us to do, it frees up our resources so we can still do the bridge load that we do. And so what we're trying to do is jump ahead of the schedule here. And so by the time that process goes through, they can be working and replacing bridges that are probably just going to become an SD. And so it just allows us to get a whole bunch of these bridges replaced sooner and quicker. One other thing is for, like, example of this is our interstate. I'm looking at more corridor zone related bridge rehab projects. That way you're doing a whole bunch of bridges in a zone or a corridor. We seem to have gotten away from that in previous years. We did a lot of that back in the 70s, 80s, and even early 90s, and we kind of seemed to have gotten away from that. So they're looking at that again and trying to do that way. It's just more efficient way to manage your bridges. I mean, less lane closures. I mean, if you did one bridge here this year and 3 years later you come back and work on that bridge, I'm just trying to be a lot more efficient how we group the bridges that are in similar deterioration in similar locations. Related to our concrete decks, looking at other DOTs and how they manage their decks, whether it be inspection, preventive maintenance, different types of testing. And then last, review of inspection procedures. We've made quite a few changes on how we inspect our decks now. We're using Impact Echo on our interstate system right now this year. We actually did all of our bridges on our interstate. We did Impact Echo on. That way we can get a true snapshot of the condition of these bridges, because as I mentioned earlier, these bridges, we know they're going to be coming due for a deck work, whether it be a replacement or an overlay over the next 10 years. So we really wanted to get a good snapshot of what we have. And that way we can start planning and forecasting out. And that way we don't have any surprises and try to prevent these things from becoming SD. So just kind of conclusion here, some of the things that we've realized or come to find out over the past 10 years of using this deficiency formula prioritization process is you need a systematic process. The results need to be reproducible. The process also has to be a little bit, you have to be able to allow for some flexibility. Not everything fits in a square box. I mean, obviously funds are limited. If you have a successful bridge management process, allows you to maximize those funds, makes it easier to justify those funds. One thing we found is it definitely provides or helps out in less political intervention. When you have a systematic process, it's easier to say no to projects that aren't really needed or requests. Also allows, it prevents scrutiny of your bridge program because you have a well-defined process. And obviously you need some performance measures to kind of grade your process and see how effective it is. And then last, probably most important, you need to periodically review that process, as we found and as we're starting to make changes now. What worked 10 years ago might not work now or might not work 10 years from now. So you constantly have to review it and evaluate it, see if any changes need to be tweaked or whatnot. So that's all I have. Any questions? Okay.
How far along are you with the design build contract? Because we're experiencing the same thing with the pipes. We've tried all kinds. It is draining our design resources because a small pipe takes as much effort as a bridge when it comes to environmental impacts, utilities, it's all the same project development costs and time.
What was the question again? I'm sorry.
Well, how far along are you? Because we had the same thoughts about doing a design build contract.
We're in the early stages.
Okay.
The early stages. We know the group of bridges we want to work on. It's just a matter of getting everything set up.
Are they mostly like small pipes, or are they?
No, they're MBI structures.
Oh, okay.
They're MBI length pipes, but what they are is they're pipes that we know we can put reinforced concrete pipe back.
Right.
So it's just strictly that.
Okay.
And they're all federal length.
Yeah, all federal MBI length. Yeah, federal length, federal funding.
Any other questions?
I got off easy compared to New Jersey.
Thanks, Jason.